All right, let's dive into the world of AI today. We're taking a deep dive into a research paper that's causing quite a stir. We're talking MiniMax-01. And this AI model is pushing the boundaries of what people thought was even possible. You've probably heard a bit about it already.
Yeah, it's definitely not just hype. The paper is called MiniMax-01, Scaling Foundation Models with Lightning Attention. It comes directly from the MiniMax team. And let me tell you, it's a dense one. They really get into the nitty-gritty technical details. But don't worry, we're here to break it all down for you. We'll pull out the most fascinating parts.
Okay, so imagine this. You're trying to teach someone calculus, but instead of giving them a textbook, you hand them an entire library. That's kind of what it's been like for AI, trying to deal with huge amounts of information.
Exactly. And that's the challenge that MiniMax-01 is tackling head-on. This model can handle a context window of 1 million tokens. That's like processing 200 pages of text all at once.
Wow, that's incredible. And they didn't just stop at theoretical limits, did they? They actually put this thing to the test on some mind-blowing benchmarks.
Yeah, they really did.
Summarizing academic papers, including figures, composing poetry, even searching the web.
They did it all. And what's really impressive is the performance they achieved, especially on the tasks that need a really deep understanding of context. They pushed the model to its limits, and it delivered some pretty remarkable results.
So what's the secret sauce? What makes MiniMax-01 so special? I know they talk about lightning attention, which honestly sounds kind of like a superpower.
Yeah, it kind of is. Lightning attention is a brand new type of attention mechanism. It's much more efficient than traditional methods, especially when you're dealing with those massive chunks of information we talked about. Remember the analogy of trying to teach someone calculus using an entire library? Well, imagine if they could process whole sections of books at once, instead of having to read word by word.
No, that would definitely speed things up. So are they suggesting that this is how the human brain works?
Well, they definitely drew some inspiration from the way humans process information. But it's not a direct copy. It's more about finding computational methods that are as efficient as possible. And that's becoming even more important as AI models become larger and more complex.
That makes sense. Okay, so lightning attention is one key innovation. But they also mentioned this mixture of experts thing, or MOE for short. What's that all about?
So think of it like this. You have a team of specialists, each with their own unique area of expertise. When a complex problem comes up, you route it to the expert who's best equipped to handle it, right? Well, that's basically what MOE does. MiniMax-01 has 32 different experts, and each one is tuned for a specific type of processing.
So it's like having a whole brain trust inside this one AI model. But with 32 experts, how do they avoid stepping on each other's toes? How does the model know which expert to call on?
That's where the magic of routing comes in. The model actually learns which experts are most likely to be helpful for a specific task. It's kind of like a triage nurse in a hospital directing patients to the right specialist.
Ah, I see. So are these experts all working on different parts of the problem at the same time, like some kind of parallel processing?
Yep, exactly. And this parallel processing is another key factor in MiniMax-01's efficiency. It allows the model to tackle much larger and more complex problems without getting bogged down.
So it's like having 32 brains all working together on the same problem. Pretty impressive stuff. But I'm guessing building an AI model like this doesn't happen overnight. They must have needed a ton of data to train it.
Oh, absolutely. We're talking about a truly massive amount of data. And they weren't just throwing any old data into the mix either. They were extremely selective about the sources they used. And they put in place a really rigorous filtering process to ensure the highest quality data possible.
So they were really focused on giving MiniMax-01 the best possible education, so to speak. What kind of materials were they using?
Think of it like building a curriculum for the ultimate AI bootcamp. They used a diverse range of sources: academic literature, books, web content, programming code, and more. They wanted to expose the model to as much high-quality information as they possibly could.
And they even used another AI to help with the filtering process, right? Kind of like a teaching assistant grading the essays.
That's exactly right. They leveraged the power of a previous generation AI to assess the quality of the data. It helped them identify passages that were well-written, informative, and aligned with the values they wanted to instill in MiniMax-01.
It's pretty mind-blowing to think about AI being used to train other AI. It's almost like a generational passing of knowledge.
It really is. And it highlights how iterative AI development is. Each generation builds on the knowledge and capabilities of its predecessors, leading to these increasingly sophisticated systems that we're seeing today.
So they've got this massive amount of high-quality data, and they've built this incredible architecture with lightning attention and MOE. But how did they actually put MiniMax-01 through its paces? How did they test its ability to handle all that information?
They designed a series of demanding long context benchmarks. One of the most interesting ones is called multi-round needles in a haystack, or MRNIAH for short.
Okay, that sounds pretty intense.
It is. Imagine having a conversation with someone who remembers absolutely everything you've ever said, even over thousands of interactions.
Okay, that's both impressive and a little bit terrifying. I can barely remember what I had for breakfast yesterday.
Right. Well, it's a testament to the model's ability to retain and recall information from very long sequences of text. And MRNIAH is specifically designed to test this ability. It buries crucial pieces of information within a huge amount of irrelevant text.
So it's like trying to find a specific grain of sand on a beach, but MiniMax-01 was able to find those needles in the haystack.
It did. And it did it remarkably well. The results on MRNIH, along with the other long context benchmarks, showed just how effective their approach is. It's a real game changer for AI, especially when dealing with complex real-world problems.
So MiniMax-01 wasn't just limited to these kind of synthetic benchmarks, right? They also tested it on some real-world tasks.
Yeah, they definitely did.
What were some of those?
They challenged it to summarize academic papers, complete with figures. Imagine handing a dense scientific paper to someone and asking them to pull out the key findings, while also incorporating the relevant visuals into their explanation.
That sounds like a task that a lot of researchers wish they could delegate.
Right.
How did MiniMax-01 handle it?
It did a fantastic job, actually. It accurately identified the key takeaways from the paper, provided a concise summary, and even pulled out the correct figures to support its points.
That's amazing. It's like having a research assistant that can read and understand complex academic material. What other real-world tasks did they test?
Well, they also had to translate the entire book, The Little Prince, into a lesser-known language. This really proved its ability to handle very long, continuous pieces of text, while also capturing the nuances of style and meaning.
Wow, that's a lot to ask of an AI model. It sounds like MiniMax-01 is really pushing the boundaries of what's possible in AI. But it's not just about performance, is it? They also took the ethical considerations of building such a powerful AI very seriously.
Oh, absolutely.
Yeah.
They understood the potential risks. And they took a number of steps to ensure that MiniMax-01 is used responsibly. And it all starts with the data. Remember how we talked about how carefully they curated the training data to remove anything harmful or biased?
Yeah, they wanted to make sure that the model was learning from the best possible sources. But did they do anything else to ensure its safety?
Yeah, they developed a reward model. This encourages the AI to be truthful, helpful, and harmless in its interactions. It's almost like building a moral compass into the model itself.
So it's not just about what it can do, but how it's trained to use its abilities. That's a really crucial distinction. But let's zoom out for a second and talk about the bigger picture. How does MiniMax-01 fit into the quest for artificial general intelligence, or AGI?
That's a great question. AGI is the ultimate goal of many AI researchers, It's about creating systems that can truly understand and reason like humans. And MiniMax-01, with its ability to process information on a massive scale, adapt to different tasks, and even incorporate visual information, seems to be a step in that direction.
So are we saying that this is the dawn of true AI? Are we on the verge of having machines that can actually think like us?
Well, I wouldn't go that far just yet. But what is fascinating is that models like MiniMax-01 are pushing us closer to understanding what's possible. They're raising questions we never even thought to ask before.
And that's what's so exciting about this field, right? We're constantly pushing the boundaries of knowledge, and it's impossible to predict where it will lead. And that brings us to a really crucial question for our listeners to ponder. Do you think models like MiniMax-01 are actually bringing us closer to AGI? And what are the implications, both positive and negative, of developing AI that can rival human intelligence?
Yeah, it's definitely something to think about.
It's a question that's worth some serious thought. And as these technologies continue to evolve at such a rapid pace, we need to be prepared for the challenges and opportunities that lie ahead. But before we delve into those kind of philosophical questions, let's take a closer look at the technical nuts and bolts of how the MiniMax team achieved this remarkable feat. Let's start with that game-changing lightning attention. What's the secret sauce behind its efficiency?
Now, let's peel back the layers and see how lightning attention actually works.
Yeah.
So you mentioned it's much more efficient than traditional methods.
Yeah.
Especially with those massive amounts of data.
Yeah, I'm all ears.
Right. Well, traditional attention mechanisms like the popular softmax attention, they really struggle when you throw really long sequences of information at them.
It's like they get bogged down trying to process everything at once.
Exactly. The computational cost explodes as the sequence gets longer. But lightning attention uses a clever trick, a linear attention mechanism that stays efficient no matter how long the sequence gets.
So it can handle those 200-page chunks of text without breaking a sweat.
Precisely. It breaks down the problem into smaller, more manageable chunks, processing information within those chunks, while still keeping track of the relationships between different chunks.
So it's not just looking at each piece in isolation, it's understanding the bigger picture, how all the pieces fit together.
Right. Now here's where things get even more interesting. Remember how I mentioned that MiniMax-01 uses a hybrid approach, combining lightning attention with some traditional softmax attention?
Yeah, I was wondering about that. Why not just go all in on lightning attention if it's so much better?
Well, it turns out there are some trade-offs. Pure lightning attention is incredibly fast for long sequences, but it can sometimes miss subtle nuances of language that softmax attention is better at handling.
So it's like having a race car that can speed down the highway, but might miss some of the scenic details along the way.
That's a great way to put it. The MiniMax team found that a hybrid approach, using lightning attention for most layers and strategically adding some softmax attention, gave them the best of both worlds.
It's like having a team of specialists, each with their own strengths, working together to achieve a common goal.
Exactly. This hybrid design is reflected in the impressive performance they achieved on those long context benchmarks. They even compared it head-to-head with models using only softmax attention or other types of linear attention.
And how did it stack up?
The hybrid model consistently outperformed the others, especially when it came to handling those really long sequences. It's a testament to the power of combining different approaches to optimize performance.
So lightning attention is definitely a key ingredient in what makes MiniMax-01 so special. Now, let's talk about that other cool element, mixture of experts, or MOE. I'm still trying to wrap my head around how that works in practice.
Okay, imagine you're building a house. You wouldn't hire one person to do everything, right? You'd bring in specialists, plumbers, electricians, carpenters, each with their own expertise.
Makes sense. You want the right person for the job.
Exactly. That's the core idea behind MOE. Instead of having a single massive neural network trying to handle everything, you divide it into smaller, specialized networks called experts.
And MiniMax-01 has 32 of these experts, each with its own area of focus.
That's right. And here's the key. When the model is processing information, it doesn't activate all 32 experts for every single task. It has a routing mechanism that figures out which experts are most likely to be helpful for a given input.
So it's like having a project manager who knows which team member to call on depending on the specific requirements of the task.
Precisely. And this specialization allows the model to handle a much wider range of tasks with greater efficiency. It's like having a brain surgeon on call for medical questions, a Shakespearean scholar for poetry analysis, and a coding guru for debugging programs, all within the same AI model.
That's pretty incredible. But managing a team of 32 experts can't be easy. How does the model ensure that each expert is pulling its weight and that they're all working together smoothly?
The routing mechanism is key here. It's a sophisticated system that figures out which experts are most likely to be helpful for a given task. It's constantly learning and adapting as the model is trained.
So it's like the model is constantly refining its understanding of each expert's strengths and weaknesses.
Exactly. The model keeps track of which experts perform well on different types of tasks. And it uses that information to improve its routing decisions over time. It's a dynamic process. That ensures the MOE architecture doesn't become unwieldy.
This whole concept of specialized AI agents working together is fascinating. It seems like a powerful way to address complex, multifaceted problems.
It is. And the MiniMax team put a lot of effort into refining this routing system. They experimented with different algorithms and carefully analyzed the performance of each expert.
So they really thought through how to make this complex architecture work seamlessly. Now, let's shift gears a bit and talk about how they actually trained this behemoth of a model. We know it required massive amounts of data, but what were their specific strategies for selecting and preparing that data?
They were incredibly meticulous about data curation. They understood that the quality of the training data is just as important as the quantity. You know what they say, garbage in, garbage out.
Absolutely. So how did they go about building this high-quality training corpus?
They pulled from a diverse range of sources. It's kind of like you could call it an AI boot camp curriculum, packed with the richest, most diverse information they could find. Academic literature, books, web content, programming code, the whole shebang.
Sounds pretty comprehensive. But didn't they also use another AI to help with the filtering process?
They did, yeah. They leveraged the capabilities of a previous generation AI to help curate the data for this even more powerful model. Think of it like a graduate student assisting a professor with their research.
So they're using existing AI to help train even more advanced AI. That's pretty meta.
It is. And it was a clever way to scale their data curation efforts. This previous generation AI had been trained to assess the quality of text. So they used it to identify passages that were well-written, informative, and aligned with their goals for MiniMax-01.
So it's like having an AI teaching assistant, grading the essays and making sure the content meets the high standards of the course.
Exactly. And this AI-assisted filtering process allowed them to sift through a truly massive amount of data and select only the highest quality information for training.
That's really impressive. But data curation was just the first step, right? They also had to think about how to structure and format the data to make it easier for the model to learn.
Oh, absolutely. They experimented with different ways of presenting the information, trying out various document formats, text styles, and even incorporating visual elements.
So they were thinking about things like using bullet points for lists, headings to separate sections, and even incorporating images and diagrams to illustrate key concepts.
Exactly. They found that certain formatting choices could significantly improve the model's ability to learn from the data. Just like students learn better from a well-structured textbook with clear illustrations than from a jumbled collection of notes.
So they were really focused on optimizing the learning experience for MiniMax-01, making the information as accessible and digestible as possible.
Right. And this attention to detail and data formatting really highlights their commitment to maximizing the effectiveness of the training process. They weren't just throwing data at the model, they were carefully crafting the learning experience.
Now, training a model of this scale isn't just about feeding it data, right? It's also about choosing the right training methods and algorithms. What were some of the key strategies the MiniMax team used to train MiniMax-01 effectively?
They used a multi-stage training process, starting with pre-training on a massive data set of text and code. It's like laying the foundation for a skyscraper.
So this was the foundational coursework of their AI bootcamp, giving the model a broad base of knowledge to build upon.
Exactly. During this pre-training phase, they used a very common technique for training language models, predicting the next word in a sequence. This helps the model develop a deep understanding of language structure, grammar, and semantics.
It's like teaching a student the rules of grammar before asking them to write an essay.
Precisely. And once the model had this solid foundation in language, they moved on to more specialized training phases, using techniques like supervised fine-tuning and reinforcement learning.
So this was where they started to refine the model's skills in specific areas, like summarizing text or translating languages.
Exactly. For supervised fine-tuning, they provided the model with specific examples and guidance. This helped it learn to perform those tasks accurately. And for reinforcement learning, they rewarded the model for producing outputs that aligned with human preferences. This is a powerful technique for training AI agents to perform tasks in complex environments.
So they were essentially giving the model a virtual pat on the back for doing a good job, encouraging it to learn and improve over time.
Right. And through this combination of pre-training, fine-tuning, and reinforcement learning, they were able to shape MiniMax-01 into a highly capable and adaptable AI model. It's a testament to the power of thoughtfully designed training regimes.
I can imagine that training a model of this scale wasn't without its challenges, especially on the computational front.
Oh, you're absolutely right. Training a model with hundreds of billions of parameters requires enormous computational resources. It's like trying to run a complex simulation on a single, outdated computer. The system would simply crumble under the pressure.
So how did they overcome these computational hurdles?
They had to develop some innovative optimization techniques to make the training process feasible. One key innovation was expert parallelism. This allowed them to distribute the training workload across multiple GPUs. It's like having a team of engineers working on different parts of a complex project simultaneously, allowing for faster progress.
So instead of trying to train the entire model on a single machine, they divided the workload and leveraged the power of parallel processing.
Precisely. And this expert parallelism, combined with other optimization techniques, allowed them to train MiniMax-01 in a reasonable amount of time, despite its massive size.
It sounds like they had to push the boundaries of computing as much as they were pushing the boundaries of AI.
They did. It was a remarkable feat of engineering. And it underscores the importance of not just developing innovative AI architectures, but also finding ways to make those architectures scalable and trainable using the resources we have available.
Now, we've talked a lot about the technical aspects of MiniMax-01, but let's not forget the human element. The MiniMax team was very intentional about addressing the ethical considerations of building such a powerful AI. What were some of the key steps they took to ensure MiniMax-01 is used responsibly?
They took a multifaceted approach, recognizing that it's not just about preventing harm, but also about promoting positive values. They started by carefully curating the training data, filtering out anything that could potentially lead to harmful or biased outputs.
So they were very careful about what they fed the model, making sure the training data reflected the values they wanted to see in the AI's behavior.
Exactly. They also developed a reward model that encouraged the AI to be truthful, helpful, and harmless in its interactions. It's like building a set of ethical guidelines into the model's decision-making process.
So it's not just about what the model is capable of doing, it's about how it's incentivized to use its abilities.
Right, and they didn't stop there. They also incorporated specific training data designed to address potential safety concerns. They wanted to expose the model to situations that could test its ethical boundaries, so to speak, and teach it how to respond appropriately.
So they were proactively addressing potential ethical challenges by creating training scenarios that force the model to make difficult choices.
Exactly. And through this combination of data curation, reward modeling, and targeted training scenarios, they were able to imbue MiniMax-01 with a strong sense of ethical responsibility.
It's encouraging to see a team taking the ethical implications of their work so seriously, especially when dealing with technology this powerful. Now, we know MiniMax-01 isn't just a language model. It also has impressive multimodal capabilities, seamlessly integrating text and visual information. How did they achieve this fusion of vision and language?
They adopted a popular approach called VTMLP-LLM, which combines a vision transformer, a multi-layer perceptron, or MLP projector, and a large language model, or LLM.
It sounds like a powerful combination. Could you break down what each of those components does?
Sure. The vision transformer, or VT, analyzes visual information, extracting features and patterns from images, just like our brains do.
So it's like the eyes of the AI, allowing it to perceive and understand the visual world.
Exactly. Then the MLP projector acts as a bridge between the visual and language domains, converting the visual features extracted by the VT into a format that the LLM can understand.
It's like a translator, converting the language of images into the language of text.
Precisely. And finally, the LLM, which in this case is the core MiniMax language model, takes these translated visual features and integrates them with its existing knowledge of language.
So it's like the brain of the AI, combining the information from its eyes and its language centers to create a unified understanding of the world.
That's a great way to visualize it. And this VT MLP LLM architecture allows MiniMax-01 to perform a wide range of multimodal tasks, from image captioning to visual question answering.
It sounds like a powerful tool for understanding and interacting with the world around us. But I imagine integrating vision and language can't be easy. What were some of the challenges they faced in training the model to handle both modalities effectively?
Well, one of the biggest challenges is finding enough high-quality training data. That includes both visual and textual information. It's like trying to find a bilingual dictionary for the languages of images and texts. It's not something you can just pick up at the bookstore.
So they had to get creative in finding ways to source and create this multimodal training data.
Exactly. They scoured museums, libraries, and the internet, searching for examples of visual information paired with textual descriptions. They also used data augmentation techniques to artificially increase the size of their training dataset.
Data augmentation, what does that involve?
It involves taking existing examples of paired visual and textual information and creating variations on those examples. For example, they might crop an image or paraphrase the text to create new training data points.
So they were essentially finding clever ways to stretch their existing data and create more training examples.
Right. And this, combined with their careful curation efforts, allowed them to build a sufficiently large and diverse multimodal training dataset.
But even with a good dataset, training a multimodal model can be tricky. How do they ensure that the vision transformer, the MLP projector, and the LLM were all learning to work together effectively?
They took a multi-stage training approach, starting by pre-training the vision transformer and the LLM separately on their respective modalities. It's like giving each component some individual training before asking them to collaborate on a joint project.
So they were making sure each part had a strong foundation in its own domain before bringing them together.
Exactly. And once these individual components had a solid foundation, they began training the MLP projector to bridge the gap between vision and language. This helped the model learn how to translate the visual features extracted by the VAT into a format that the LLM could understand.
It's like giving the translator some practice in converting between the two languages.
Right. And finally, they fine-tuned the entire ViT MLP LLM architecture together on the multi-modal training dataset. This allowed all the components to learn to work together seamlessly.
So they were essentially orchestrating a grand finale, bringing all the pieces together for a harmonious performance.
Exactly. And through this multi-stage training process, they were able to achieve a smooth and effective integration of vision and language in MiniMax-01.
This whole process is a testament to the power of thoughtful training regimes and the importance of breaking down complex problems into smaller, more manageable steps. Now, we've covered a lot of ground, but there's one more crucial aspect of MiniMax-01 that we haven't discussed yet: its ability to handle incredibly long contexts, up to millions of tokens. How did the MiniMax team achieve this remarkable feat of long context processing?
Well, they knew that traditional attention mechanisms struggle with long sequences because of their computational complexity. It's like trying to have a conversation with 1,000 people at once.
Yeah.
The amount of information to process becomes overwhelming, so they focused on optimizing the model's attention mechanism.
So they needed a way to handle all that information without getting bogged down.
Exactly. They turned to an alternative approach called linear attention, which maintains a constant computational complexity regardless of the sequence length.
So no matter how long the conversation gets, the model can keep up without breaking a sweat.
Precisely. And they cleverly combined linear attention with traditional softmax attention to get the best of both worlds. It's like a conductor leading an orchestra, using both broad strokes and precise gestures to create a harmonious symphony.
So they were able to leverage the strengths of both approaches, combining speed and accuracy, to create a truly powerful attention mechanism.
Right. And this hybrid approach, along with other optimization techniques like data packing and LASP+, allowed them to train MiniMax-01 on sequences of unprecedented length. They were essentially giving the model a photographic memory, allowing it to recall and synthesize information from vast amounts of text and code.
That's incredible. But this long context processing prowess wasn't just a theoretical exercise, was it? The MiniMax team put it to the test on some pretty impressive benchmarks, right?
They did. One of the most challenging benchmarks was called multi-round needles in a haystack, or MRNIAH.
That sounds intense. What exactly did this benchmark involve?
It involved having the model participate in a long and complex dialogue, remembering details from previous turns, and using that information to answer questions and complete tasks.
So it's like having a conversation with a friend who remembers every single thing you've ever said, even the most trivial details.
Exactly. And MRNIAH was specifically designed to test the model's ability to track information over very long sequences of text, pushing the limits of long context processing.
So they were basically throwing a conversational marathon at the model, seeing how well it could keep up and retain information over an extended period.
Right. And to make things even more challenging, the needles and information the model needed to retrieve were often buried deep within a haystack of irrelevant text.
So it's like trying to find a specific grain of sand on a beach, a truly daunting task.
Exactly. And despite these challenges, MiniMax-01 performed remarkably well on the MRNIAH benchmark, demonstrating its ability to process and recall information from extremely long contexts.
So it was able to find those needles in the haystack, proving its long context processing prowess. And this achievement really highlights the potential of linear attention and other optimization techniques for unlocking new levels of AI capability. Now, MiniMax-01 wasn't just tested on synthetic benchmarks, it was also evaluated on real-world tasks like summarizing academic papers and translating an entire book. How did it perform on these more practical challenges?
It performed exceptionally well. For the academic papers, they gave it a PDF of a research paper and asked it to summarize the key findings, incorporating relevant figures from the paper into its summary.
So it's like having an AI research assistant that can read a dense academic paper and distill the most important information,
including visual aids, into a concise and easy-to-understand format.
Exactly. And MiniMax-01 was able to do that.
It was. It accurately identified the key takeaways from the paper, it summarized the findings, and it even correctly identified and inserted the relevant figures into its summary.
That's remarkable. It's like having a personal tutor that can guide you through complex academic material, highlighting the most important points and providing visual aids to help you understand. What other real-world tasks did they test?
Well, they also tested its ability to translate the entire book, The Little Prince, into a lesser-known language. This really pushed the limits of its long context translation capabilities.
So they were essentially asking the model to become a literary translator, capturing not just the literal meaning of the text, but also its nuances, style, and emotional impact.
Exactly. And MiniMax-01 rose to the challenge, producing a high-quality translation that preserved the essence of the original work.
It's like having an AI polyglot who can speak the language of literature fluently, conveying the beauty and meaning of a text across linguistic barriers.
Precisely. And these real-world evaluations demonstrate that MiniMax-01 isn't just a theoretical marvel. It has practical applications that could revolutionize how we interact with information.
Now, we've talked a lot about how the MiniMax team trained MiniMax-01, but they also put a lot of effort into evaluating its performance. What were some of the key metrics they used to assess the model's capabilities?
They used a combination of standard benchmarks and custom evaluation metrics. They recognized that evaluating a model as complex as MiniMax-01 requires a multifaceted approach.
So they weren't just relying on off-the-shelf tests. They were also tailoring their evaluations to really probe the model's abilities.
Exactly. One of the standard benchmarks they used was called MMLU, which stands for Massive Multitask Language Understanding. It measures the model's ability to perform a wide range of language-based tasks, covering topics like science, history, mathematics, and social studies.
So it's like an academic decathlon for AI, testing the model's knowledge and reasoning abilities across a diverse set of subjects.
That's a great analogy. And MiniMax-01 scored exceptionally well on the MMLU benchmark, demonstrating its broad knowledge base and its ability to apply that knowledge to solve problems.
So it proved it could hold its own against other top-performing AI models, demonstrating its mastery of multiple academic disciplines.
Right. They also evaluated the model's performance on more specialized tasks, like code generation and mathematical reasoning.
So they were testing its ability to not only understand language, but also to create it and use it to solve problems.
Exactly. And for these specialized tasks, they used a combination of standard benchmarks and custom evaluation metrics. For example, they designed tasks that required the model to understand and apply mathematical concepts, like solving equations or proving theorems. It was essentially like giving the model a math exam.
And how did it fare on these more challenging tests?
It did really well. Across all these evaluations, MiniMax-01 consistently performed at or near the top of the leaderboard, demonstrating its impressive capabilities. They even challenged it to generate code that not only was grammatically correct, but also functionally sound.
So they weren't just looking for superficial fluency. They wanted to see if the model could actually create working code.
Exactly. Yeah. And it succeeded, proving that it could grasp complex programming concepts and apply them in practical ways.
That's truly remarkable. It seems like MiniMax-01 is setting a new standard for AI capabilities. But as impressive as its technical achievements are, it's equally important to consider its potential impact on society.
Absolutely. Developing powerful AI systems like MiniMax-01 raises important questions about how these technologies will be used and what implications they hold for the future.
It's a topic that requires careful consideration and thoughtful dialogue. As we continue to push the boundaries of AI, it's crucial that we engage in conversations about its ethical implications and work together to ensure that these technologies are used responsibly and for the benefit of all.
I completely agree. The future of AI is a shared responsibility, and it's up to all of us to shape its trajectory in a way that benefits humanity.
Well said. And as we conclude this deep dive into MiniMax-01, I want to leave our listeners with a thought-provoking question. Do you believe that models like this, with their incredible capabilities and potential, are bringing us closer to a future where AI rivals human intelligence? And if so, what opportunities and challenges might such a future hold?
It's a question that sparks a lot of debate, and there's a lot of speculation out there. Are we really on the path to creating AI that can think like us? Or is that still just science fiction?
Yeah, it's a big question. One thing that really caught my eye in the paper was their mention of potentially open sourcing future versions of this model. That seems like a pretty bold move, especially considering how powerful it is.
It is bold.
Yeah.
And it's definitely generated a lot of discussion in the AI community. There are pros and cons to think about. On the one hand, open sourcing such a powerful tool could really democratize access to cutting-edge AI. Researchers and developers all over the world could experiment with it and innovate.
It's like opening up that AI bootcamp we were talking about earlier to anyone with an internet connection. And that could lead to some incredible breakthroughs, couldn't it?
Absolutely. But of course, there are risks that come with making such a powerful technology so widely available. there's always the concern that it could be misused, either intentionally or unintentionally.
Right. It's like giving everyone access to a powerful toolbox. Without any guarantee, they'll use the tools responsibly. I imagine security and safety are major concerns.
Oh, absolutely. And those concerns are even bigger when you're dealing with AI as powerful as MiniMax-01. That's why it's so important to have these open and honest conversations about the potential risks and benefits of open sourcing this kind of technology.
It's a balancing act, isn't it? Weighing the potential for good against the potential for harm. It seems like responsible development and deployment are going to be absolutely crucial as AI continues to advance.
I couldn't agree more. And that responsibility falls on all of us. Researchers, developers, policymakers, the general public. We need to be having these thoughtful discussions about the future we want to create with AI and make sure that these technologies are aligned with our values.
This deep dive has been really eye-opening for me, not just in terms of seeing the incredible progress being made in AI, but also in making me think more deeply about the ethical implications. It's clear that AI is going to become even more intertwined with our lives, so having these conversations now is more important than ever.
It really is. We need to approach these advancements with a mix of excitement and caution, making sure we're harnessing the power of AI for good, while also being very mindful of the potential risks.
Well said. I think we've covered a lot of ground today. We've explored the technical innovations behind MiniMax-01, from lightning attention to MoE, and we've delved into the ethical considerations and the potential impact on society. It's been a fascinating journey.
It really has. And I hope our listeners have come away with a deeper understanding, not just of the capabilities of this particular model, but also the broader trends that are shaping the future of AI.
And for our listeners who are eager to experience the power of MiniMax-01 firsthand, the research paper actually provides links to the chatbot and API, so you can actually see this incredible technology in action.
Yeah, it's definitely worth checking out. And as you interact with MiniMax-01, I encourage you to keep those big questions in mind. How is AI changing the world? What role do we want it to play in our lives? And how can we ensure its development and deployment are guided by ethical principles?
Those are questions that are going to continue to challenge and inspire us as we venture further into this age of artificial intelligence. Thanks for joining us on this deep dive, and we'll see you next time for another exploration of cutting-edge technology.